Good evening, everyone. So, in the morning session, we are trying to discuss about the hash set internal implementation. So, how it is working. We need to understand this particular implementation section here. Okay. So, first we'll identify what are all the methods we are having inside this particular hash set here. Okay. I'm going to close all the information. So, observe carefully. So, what are the specific information we are having inside this particular set interface? These are all the methods. Okay, these methods are copied from the which interface? Basically collection interface, because this particular set internally it is trying to extend from this particular collection interface. Okay, and finally these are all the methods we implemented inside, like we declare inside this particular collection interface. The same method we are trying to copy into inside this particular set interface. Okay, so now we'll understand how this particular set interface is going to work. For this particular set interface, now I'm going to implement hash set demo, and we'll try to implement the hash set related example inside this particular class. Okay, so we already discussed in the morning session, hash set is the one of the implementation of this particular set interface. Okay, and here now what I will do, I'm going to provide the integer related section here. The generic type, what I'm trying to providing here I'm trying to providing integer. Okay, so I'm going to write this particular HS is a reference variable, and I'm trying to create the object here. How many constructor we are having? Observe carefully, we have a different types of constructors here. Okay, now observe carefully what I'm doing here. We need to understand the different constructor. First one is a default constructor. Okay, and the second one is a collection. One more collection we can pause while creating this particular hash set object. And the third constructor, now we can see we can provide the initial capacity. Okay, we can provide this particular initial capacity here. So if you are interested to provide the explicit capacity, we can call this particular third constructor. Otherwise, we can provide the one more constructor which is expecting initial capacity with the load factor. Okay, so we'll discuss about this particular load factor, how it is going to work. So how many we are having? We are having around 4 constructors here. Getting the point? We are having 4 constructors. Now we need to understand this particular 4 constructors. So how each and every constructor it is going to work internally. Okay. So now observe carefully. First I will identify the default constructor here. Getting the point? So whenever we are discussing about this particular default constructor, what we need and what we need to understand internally, if I'm going to open this particular hash set, what we are doing is we are trying to create a hash map here. Okay, so as I explained earlier, Hashmap basically what exactly it will available? It is a key value store. Here we identified Hashmap is expecting e comma object. Getting the point? Here we are having 2 generic properties. So first one is a e, and second one is a object. So e stands for element here, like we are going to store the particular elements here, and the second parameter what we are doing is we are going to provide the object here. And what is an object we are going to provide? This is an object. So whatever it is presented here, this we are going to provide. So something like we can easily understand key value. Okay, this particular key, every time it is going to modify the value, it is a constant value. This particular value we are not going to modify. Every time we'll pause this particular same references. So carefully observe whatever this particular present we are having, we are going to provide. Now observe carefully what we are doing is we are trying to create a hash map object here. Okay, hash map object we are creating. Now what I will do, I will move inside this particular hash map, how this particular example it is going to work. So now you can see this is calling internally load factor equals to default to load factor. So what is the default to load factor we are having? Now I will identify what is the default to load factor here. Where this default to load factor is defined? Now I'm trying to move on to the class level. This is we are discussing about the hash map. Okay, this is we are discussing about the hash map. Now observe carefully. Here, this is the default load factor. Getting the point? So 0.75. So something like here, this is the hash map object is created. Okay, how many elements we can insert? 0 to 10, because internally it will store as a key value pair. So whenever the 75% is completed, okay, whenever the 75% is completed, it will try to create a one more bigger hash map. Okay, same thing, it will copy the old object, and we'll have a some space, we'll try to insert the new records here. Getting the point? So this is the default load factor it is going to indicate here. Something like once a 75% of this particular hash map is internally filled, getting the point, it will try to come up with a new object here. Getting the point? So this is the default load factor it is going to work internally. Now what is the capacity we are having? Now we'll understand here the capacity what exactly we are going to have. So you can see here we are having, this is the default capacity. How many we are going to store? Something like 16. Okay, so how many values we are going to store? We'll try to store the 16 values by default. Array list, how many we are going to store? 10. And hash map, how we are going to store? Something like a 16 here. Getting the point? So this is, we need to understand how this particular hash map internally it is creating. So we'll go back to the hash set here. So right now we will not discuss more about this particular hash map. Most probably we'll focus more on the what is the implement, like information is implemented inside this particular hash set here. Okay, this is important, we need to understand here. Okay, now what we need to understand here, we are trying to create this particular hash map here. So we'll try to identify how this particular hash map is going to work internally. Now I'm going to call HS. HS is the reference variable of this particular hash set here. I'm going to call this particular add method. Okay, if you see whatever the add method we are able to see here, the two add methods here. First one is a add and another one is a add all, because set interface does not have any specific elements. Getting the point? This particular set interface, we don't have any specific elements we are having. Okay. Now what we need to understand here, I'm going to provide the value, something like 1, 2, 3 I'm providing. So once we provide this particular 1, 2, 3, so we need to understand how this particular add method is working internally. Getting the point? Because just now the line number 8 we are creating this particular hash set object here, and we identified here we can insert how many elements here? 16 elements we can insert by default. Okay, internally it will try to store as a key value pair here. We'll try to focus on this particular 16 object here. Now how this particular 16 objects are going to insert internally, that we need to understand with the help of this particular add method. Okay, so one add method we are having, and another one we are having add all method. So this add all method is going to expect as a collection, and add method is going to take as a object. So like it is like a single object, first one will take, and the second method is going to take as a multiple. Okay, first we'll see this particular add method, and later we'll discuss about the add all method. Okay, now understand here, we'll debug the code how it is going to work internally. Okay, now I'm trying to put a breakpoint line number 8 here, and I'm going to run this example in the debug mode. So now observe carefully what we are doing here. We are trying to create this particular hash set here. We'll see any information we can find inside this particular hash set here. Nothing. It is empty. Getting the point? Here we can see in the right side section, nothing is there. It is empty information. Okay. Now what I'm doing here, I'm trying to call this particular add method. So observe carefully. In the morning we discuss about the particular shortcut keyword to enter this particular method. So F5. Okay, I'm calling this particular F5. Now you can see What is the method it is calling internally? Value of method. So why it is calling this? Why it is calling it? Because here whatever the value we are providing, it's trying to converting into this particular integer. Now again I'm trying to call this particular add method. So observe carefully. This is the add method internally it is executing. We are passing this particular element here. Now you can see what I'm doing here. Map dot put. Okay, map dot put. So this is very important. We need to understand here. What is the map basically? If you go to the default constructor, okay, if you go to this particular default constructor, what we are doing is we are trying to create a map object here. Not only this particular constructor, here also we are trying to create a map object here. And now you can see here also we are creating map object here, and finally here also we are creating, and this particular asset we cannot call because this is the default access modifier. Up to this particular constructor we can discuss here. Okay, this constructor we can call outside of this particular package. Now what we are doing here, every time we are creating an object based on this particular which constructor we are going to call. Okay, so now what you understand here, with this is the reference we are using, the particular map here. So using this particular map, I'm going to call one method called put method. Okay, I'm going to call this particular put method. This is important here. So let me go back to the same method. This is the put method we are calling, and we are passing the first element, like a first parameter as a e, and the second parameter is important. So observe carefully. The second parameter what I'm passing, present. Okay, what I'm passing here, present I'm passing here. This is important. We need to understand. Whenever I'm trying to pass this particular present, what we are going to pass basically, if I'm going to provide, this is the dummy value. Okay, this is the dummy object. It's like a same object we are trying to pass multiple times here, because it is not going to modify the value, because this particular value it's same, but which one is going to modify? This particular key. Okay, so just now we discuss here, internally it is calling Hashmap, and first one we are going to call as a key, and the second one we are going to call it as a value. So whenever we are passing this particular value, it is a same value. It is a final object we created. Every time we are going to pass the same object. So this particular value we are passing as a present. Okay, and this particular key we are going to modify with this particular e. This particular e is going to modify based on the add method. Okay, based on the add method. Getting the point? This is important. We need to understand. Now what we are doing here, we are calling internally put method. So how we can move inside this particular method, we need to click on the F5 here. So whenever I'm trying to click this, now you can see we are calling internally one more method, something like put val method. And what we are doing here, first I'm going to call the hash method. Okay, and these are all the different parameters we are having. These are all the different parameters we are having. Getting the point? This is very important information we need to understand here. Okay, first we'll see how this particular hash method is going to work internally, and what is the key we are providing, something like 1 2 3. Here you can see 1 2 3 we are providing. So whenever we are providing this particular 1 2 3, so it is going to generate the hash code for this particular key. And what about this particular value? If you see, for this particular value we don't have any the specific generation something. So whatever we are getting, the value we are trying to copy here. Okay, whatever we are getting, the same thing I'm trying to press. This is important. We need to understand it and observe carefully. First, we'll move on to inside this particular hash method. Now you can see hash method. I'm calling it. Getting the point. So using this particular key, we are trying to generate the hash code here. Okay, if the key is null, we are trying to generate as a 0, and if the key is not a null, with the help of this particular key dot hash code. Getting the point? With the help of this particular key dot hash code, we'll try to get this particular h value. So this particular H we are going to return. Now, if I'm going to print this, like if I'm going to see, okay, so H is not identifying it. Now we'll identify here. Once I come back to this particular section, we'll identify how this particular hash code is going to generate here. Okay, so observe carefully what we are doing here. We are trying to call the hash method. So now observe carefully. If I'm going to inspect this, what is the hash code of this particular 123? Same. Getting the pen, because it is a number, we could not understand the proper hash code here. So with the another record we'll try to insert with a different data type. We'll see the hash code will get the some different value. Okay, after calling this particular hash method, now finally what we are going to do, we'll call this particular put val method here. Getting the pen, we'll call this particular put val method. So what exactly we are going to do using this particular put value here? Okay, what exactly we are going to do? We need to understand the. Okay, so observe carefully. We'll move on to this particular put val method. So this is very important method we need to understand here. So what I'm doing here, first one is a hash I'm trying to pass, second one is a key, and third one is a value, and fourth one we are passing some boolean values. Fourth and fifth we are passing some boolean values here. Okay, this is important we need to understand here. Now you can see these are all the nodes we are having. Getting the pen. Whatever we are discussing the linked list, we identify the same node concept here, and the same thing now we are discussing inside this particular hash set. Hash set internally, it is trying to use the hash map here. Getting the pen. It is trying to use the hash map. So now, first I am going to explain this particular node, how it is implemented internally. Now observe carefully. This is the node. First we are passing as a hash code, and another one we are passing as a key, and we are passing value, and we are trying to pass as a next node. Now, what is the diagram is going to have? Let's observe carefully the node how it is implementing internally. So this is for hash code, and this is for key, and this is for value, and this is for another node. Okay, whatever we discuss about the linked list, and the linked list we are having only three properties. Only three properties, like previous node and item as well as the next. This is for we discuss about the linked list. Okay, now this is for hash map here. Getting the point? This is for hash map. This is very important here. First here, what we are doing here we are trying to store this particular hash code here, and the second one we are trying to store this particular key, and this is for value column, and finally this is the next node references. Getting the point? This is for next node references. Whenever we are trying to create a multiple records, for example, this is the one more record I'm trying to insert into this particular hash set. Whenever we are trying to insert into this particular hash set, now what we need to understand here also same. We'll insert this particular hash code, okay, and we'll try to insert this particular key and value, and same thing for the next node. This node will trying to connect to this particular node information. So this is for okay. So observe carefully what I'm doing here. Here I'm trying to give this particular next node information. So this is very important. We need to understand here. This is for the same purpose we are going to write. Okay. Now observe carefully here what I'm doing here. Here I'm trying to providing the relations here. Like first this is the first node, and this is the second node, and this is the third node. This is the way of creating these particular nodes internally. Getting the point? This is very important. We need to understand. Okay, this is very important. We need to understand how this particular nodes are going to created internally. Now we'll come back to here where we are right now. We are trying to discuss about the put value method. Now we are at put value. Now what we need to understand here, we have a first one is a node array. Now observe carefully. This is we are going to store only one object, and this is we are going to store multiple objects. Here we are trying to make as a array type. Getting the point? This is important here. Here we are trying to store array values, and we are trying to store as a one record. And here we are having some two variables we declare, which those two variables are having int data type. And what are the two variables we are having? N comma I. Okay, these are all the very important information we need to understand here. And after this, now what I'm doing is I'm trying to check this particular condition. Okay, so whatever the condition we are having, here we are checking here something like a table. Right now, what is the table it contain? Null. Where this particular table is declared. Get in the pen. Now you can see this is the node array. Get in the pen. This is very important here. It is a node array. Now, how many elements we can store? We can store multiple elements here. Those element type basically node type here. Okay. So I'm going back to the wherever we are and do tab dot length. Where this particular tab is coming? Where this particular tab is coming here? So here we are declaring this particular tab. Okay. Here we are trying to declare this particular tab line number 622. Now, what is the length we are having? What is the length we are having for this particular tab? If I'm going to inspect the tab variable, it is not initialized basically. So just we are declaring the line number 622, and once we initialize, then only we can easily understand how this particular how many values we inserted into this particular tab, so that we can check the length of this particular information. Okay. Finally, now what I'm doing is I'm trying to call this particular n. Okay. So here we are checking this particular tab. We are checking this particular tab because here we are. What is the condition we are using? Or condition. Or condition. What exactly it will do? Either if this particular expression, first expression is satisfied true, okay, it will not check this particular second. Whenever the first one will false, like the condition will return as a false, so the next condition is going to check. What is the next condition we are having? This is the tab dot length equals to 0. But here, whatever the table we identify, this table now we are getting as a null. And the same value we inserted into this particular tab also. If you see, the tab is having null here. Okay, whatever the tab we are having null. If I'm going to like inspect this, what happening internally? We are getting an exception. Now you can see null pointer exception. Null pointer exception is getting. So why we are getting this particular null pointer exception here? Because this particular tab is null. So whenever we are having any resource we are having as a null, we cannot call the methods of methods or constructor are different properties here. Getting the point? Basically, the length is the variable we are calling. When this particular tab is having some information, then we can call this particular length. But whenever this particular tab is null, if you are trying to call this particular length here, internally, we'll get an exception. Okay, so the exception, now we identify what kind of the exceptions we are going to get. This is very familiar exception in the real time scenarios here. Getting the point? So we are going to get multiple times here, because if you are trying to pass the empty object, we'll get this particular exceptions here. So finally, now what I'm doing here, this particular tab is null, and I'm going to call this particular resize method, and whatever the result we are going to get, that result I'm trying to store into this particular tab here. Okay, so first we need to understand what we are doing here. So if you see, this is something like a big code they implemented inside this particular resize. Okay, so I will put a breakpoint. We'll try to debug one time here so that we'll understand the basic information how this particular resize method is implemented. Okay, so let me go back to the wherever we are having. Now I'm moving inside this particular resize method. This is very important method, because this method only, it will give you the object creation and inserting information. Okay, whatever the object we created, and we are trying to provide the insertion value. Now table, right now this particular table is null. Just now we discussed this particular table is null. Now I am trying to store into this particular old table. Okay, here what I'm doing here, old table equals to null will return as a 0. Otherwise, we'll try to find out the old table dot length. So what is the old capacity we are going to get? Something like 0. Getting the point? Now you can see old capacity inside this particular variable section. We can understand here. Here this variable section will give you the some more information. So here we are having 0. Okay, we identified this. After this, what is the threshold we are having? So by default, this particular threshold also we are having 0. Okay, and we are trying to providing, this is the old threshold. And now you can see these are all the two variables we declare, and we are trying to initialize them with a 0. Now whatever the variable we are having right now, all the variable are having 0 values. Okay, this is the declarations and the initialization we did here up to this particular 3 lines here. Now what is the old capacity? 0. So this particular condition will satisfy? No. Up to this particular condition, it is not going to satisfy, because here we are trying to use the greater than operator. Now you can see, if I'm going to inspect this, inspect basically whenever we are having this particular conditional blocks, or if we are having some expressions. Okay, this example we can call it as a expressions here. Now old capacity greater than 0. So if we want to check whether this particular condition satisfied or not, what we can do, Control Shift I. Okay, if you are trying to click on this particular Control Shift I, you will get a result here. So this particular result we are getting as a false. Okay, so whenever this particular condition we are getting as a false, this particular code is not going to execute here. Now you can see I'm trying to click on F6 here. So directly it is coming to this particular else if. So what we need to understand this particular else if. So what is this particular old threshold? 0. So this particular condition is also not satisfied. Now finally we are checking this particular else section. Okay. So observe carefully what we are doing inside this particular else section. Default initial capacity. Okay. So what is the default initial capacity we are having? Now you can see 16. Getting point. So just now I explained here, this is the default capacity of this particular hash map. So this is very important. Now we are not in the hash set. Now we are under the hash map class. So here it is showing the where we are having. So here you can see we are under the hash map. Why we are discussing this particular hash map here? Because hash set internally it is calling the hash map here. Okay, this is important. Okay, now observe carefully. Now we are trying to find out this particular default capacity. We identified this is the default capacity we are having 16. So we discuss here capacity is different, size is different. Getting the point? Capacity and size both are differences here. We already discussed this particular example. Now back to here. Now what I am doing here? The 690, whatever we discuss in the line number 690, what we are doing here? So if you observe carefully, this is important here. Default load factor, and it's going to multiply with this particular default capacity. So finally, this is the new threshold we are getting, something like how much we are getting? 12. Okay. Now we identify the capacity as well as we identify the threshold here. Okay. So finally, this condition again, it is not going to satisfy. Why it is not going to satisfy? This particular value we are having right now, 12. So this particular 12, it is equals to 0. So this particular expression will return false. Now you can see, and I'm trying to store whatever the new threshold we created. So I'm trying to store into the class level variable. Getting the point? This is very important. We need to understand. So this is the class level variable. Okay. So this is we created the variable at line number 676. Okay. So we only created the line number 676, and this is we created at class level. This variable we'll call it as a instance variable. Okay. And this variable we'll call it as a local variable. We already discussed whenever we are trying to discuss about the object creations, class creations here. Getting the point? So don't confuse here. These are all the important here. If I want to access this particular variable, we need an object here. Because we are in the same class, because of that, without creating an object, we are accessing it. But if we want to access this particular variable outside of this particular class, we need a object. And what about this particular variable? These variables are available within this particular method. What is the method we are discussing? Resize. Okay, we are trying to discussing about the resize method. This variable applicable within this particular resize method only. Okay, this is very important information we are discussing it. Now finally, whatever the threshold we are having, we are trying to set into this. After this is important. This is important, we need to understand. Now what I am doing here? Here I am trying to create a new node here. Okay, what is the new capacity we are having? 16. Now, what do you understand this particular 16? So once I come back to the line number 700, now you can see 0 to 15. Okay, 0 to 15, empty objects are created. Empty objects are created, and what is the type we are having? Node key comma value, and it is a array type. Getting the point? Here we are trying to store multiple records. How many objects we are going to store? By default, we are going to store 16. So 0 to 15. Getting the point? This is important. Now we understand finally we created this particular node section. Okay, after this, what is this particular new tab? Now I'm trying to set into this particular table. Getting the point? Now I'm trying to initializing. So we discuss here right side value will store into this particular left side whenever we are using this particular single equal. Okay, so don't confuse here. Now we are doing the line number 700. Whatever the newly created object, I'm trying to set into this table. Okay, after this, now what I'm doing here? What is this particular old tab? What is the old tab? So old tab, here we define here. Here we define this particular old tab. So still this particular old tab is null. So whenever this particular condition is not null, then only we'll move on to this particular code. Okay, otherwise they are trying to return this particular new tab.
Hello.
Yes.
Sorry, I'm Vinay, new to the section.
Okay.
In the companies, they will give an FSD document, right, for us to develop the by understanding that pictorial, we have to write our own code. Like we have to write the code according in that format by seeing the APIs constructing.
Okay. Okay.
So they like how can we get to know figure it out? Is I just
See, basically, first we need to understand the requirement documentation. So what they are trying to implement here. So based on that only we can identify. So basically, for example, so they are trying to implement one API, like
Okay.
to fetch the some information, and while fetching we need to add some validation, some conditions, some. So we have a
Yes.
different requirement we are going to have. So first we need to
Yes.
review the documentation properly. Then we need to
Okay.
write some model classes, what all the classes are required, and based on the classes, what are the services we are going to write, and what kind of the conditions.
Yeah. Yes. Controller DAO service, right?
Yes. So that is different, but based on that, the conditions and validations, what they are expecting. First, we need to analyze the documentation. Like it's like a ticket. We are going to get information through the tickets, so we need to review the ticket. But this section is not related to the whatever we are discussing. This is basically if you're
Okay.
trying to write any applications, we are going to use this particular hash map or hasset. So this is will identify whenever we are trying to implementing the code, if we are trying to work with a multiple object, so which class is suitable, then we are going to implement the code. So for example, most of the cases we cannot identify the hash map. We can work on the hash set or the
Yes.
linked list, or we can move on to the RE list. But that will identify based on our requirement only. If we want the duplicates, or if we want the unique elements, if we are trying to work with the key value pair, so this is based on our requirement, we are going to write the specific classes.
Okay.
Okay, so I will show you some code like how we can implement the section. Let me see, I have anything. Okay, so meanwhile we'll see like how this particular code is implemented.
Yeah. Okay.
Okay, so back to here. Now what we need to understand here, this particular condition is not satisfied because this is the new object we created here. Whatever we are trying to check this particular old tab is still it is null because of this. So simply we are returning this particular new tab here. Okay, now if I'm going to return this, what we need to understand here, we are trying to return this particular new tab, and okay, we'll see this. And after this, now what I will do, we are coming back to this particular resize method. So whatever this particular resize method is called now this particular section is setting into this particular tab. Getting the point? So tab we define as a array type. Node array type we define. And after this, now what I'm doing is I'm trying to call this particular length, and the length I'm trying to set into this particular n. So here we are doing the first two, we are doing this particular resize method calling, and whatever the return type, like whatever the return value we are returning, so the value I'm trying to set into this particular tab. After this, we are calling this particular length, and whatever the value we are going to get, the value I'm trying to set into this particular n. Okay, so these are all the basic operations is implemented inside this particular line number 624. Okay, after completion of this particular value, what is the n value we are getting? 16. How we are getting this particular 16? Because this is the default capacity we are having here. So how we are getting this particular 16? Because we are calling this particular length here. Okay, this is important. Now if you see this particular tab, what happens internally, this particular tab will contain the all the empty objects, so 0 to 15. As of now we did not insert any record here, just we are trying to focusing how these objects are creating internally. Okay, after this, now what we can understand here, we are checking one more condition, and this particular condition, if you see, this is the array type bracket we are opening. Okay, inside this particular array type bracket, we are doing some initialization. Getting the point? We are doing the initialization. After this, we are checking the condition. If this particular condition is satisfied with the null, this this particular section is going to execute. Otherwise, we are moving on to this particular else section. We'll see what is the condition is satisfying. Whatever the if condition we define here, this particular if condition is satisfied. Because right now, we don't have any records here. Now, what I'm doing here, I'm trying to call one more method here. I'm trying to call one more method here, new node method. This particular node, again, we need to understand what is doing here. And what we are passing here, hash code we are passing, key we are passing, and value we are passing, and null we are passing. Okay, so around 4 parameters we are passing. Okay, and if you see whatever the result we are getting, whatever the particular return type we are getting and the value we are trying to set into tab I. What is the tab here? It is a node type and the node is expecting array type values because it is we define as a array type and we are trying to store first records because this is the I. If you see what is we are having, not first, sorry, it is a 11th here. You can see the particular I value we are having 11 and in the 11th index here, whatever the result we are going to get from this particular new node, the result is going to store. First, we'll move on to this particular new node method, how it is implementing. Now, what you are understanding here? Basically, this is the constructor we are calling. How we are identifying it is a constructor? This is the new operator, like new keyword we are using. And after this is the constructor we are going to call. And the constructor is expecting 4 parameters. So just now we discuss here, this is the diagram of this particular node here. Okay. So this is the hash code and this is for the key and this is for the value. And the last one is a next to node references. Okay, so just I'm trying to add hash code, key value, and next node references. Whenever we are having the next node, it will make the references here. If we are trying to create one more node, getting the point. So
Sir,
right
when we
now,
give,
yes,
sorry to interrupt you, sir. Sir, here in this constructor, in the real time when we pass on the values like hash key value, so when we are going to debug, so after the at the value time, at the value or at the next, it will it go to the next number or it will in the debug mode? How it goes
see,
when it goes
basically,
to the
if you see, these are all the variables we declared at class level. So because it is one of the static class we are having, and using these methods, get key, get value, so to string, and hash code. And internally we have a one more method, set value. So this method we are going to call to insert the value and get the values.
okay.
Okay, but using this constructor we are trying to initializing the value. Whatever the properties we defined here, these properties we are going to initializing with the help of this particular constructor. So same the constructor we are calling from here. So this particular constructor is same way of calling whatever we call here. This is also one constructor. Asset is also one constructor after this particular new keyword we are calling here. Okay, same way here also they are trying to call new node here. And they are trying to pass this particular 4 parameters constructor, 4 values we are passing. And here what we need to understand, next is null and value we are having some object reference. So this is the object reference. So if I'm going to copy this, every time we'll have same reference because this is the final object. Only one time we'll create this particular final object. We will use the same object for multiple times here. And only we need to focus more on this particular key. This particular key is going to modify. Okay. So now you can see right now we are having 1, 2, 3. If you are trying to insert one more key, this key will be changed here. And now we identified we are trying to create this particular node. The node is going to store in the 11 index location. Now you can see if I'm trying to store this particular tab, here you can see in the 11th index location. Now you can see here we are having one record. So how this record is inserting? What is the key we are having? 1, 2, 3. And what is the value we are having? It is an object here. Okay, it is a object references we are passing here. So this is important we need to understand here. Okay, so how we are getting this particular 11th index location? Where is the code we provided? Let me come back to here. This is here we are doing the n-1 and we are trying to check with this particular hash code. Based on this, we are getting this particular index locations here. Okay, because of this only we are going to find out the specified index location, and in the same index location we are calling this method to insert the value. So finally in this particular tab we initialize one record. So in the which index location we initialize here, that is called 11th index location. Now this particular tab, it is going to store into this particular table also. If I'm going to open this, now you can see in the 11th index location, same record will be available. So how it is available here? Because I inserted into this particular tab, but how it is initialized into this particular table here? Getting the point. This is important here. Here we are using object references. So we discussed the one example. Java is a call by value or call by references here. Okay. Here we are using the references. Whenever we are modifying the specified references, it will affected in the all the locations wherever we are trying to use here. Because of this, line number 626 we are updating the value. It is affected into the line number 23, whatever the table we declare here. Okay. So this is all about the put value, how it is working internally. Now finally we are checking the mod count. So this is the internal purpose they implemented the mod count here. And here we are checking the size plus plus and threshold. Here the threshold basically 12 we are having, and size right now 0. It will become 1. Okay, this condition will fail. Once this particular condition will fail, so we'll come back to the one more after node insertion. So we need to understand what is this particular value we are passing. So true we are passing. We'll see what kind of the logic is implemented inside this particular after node insertion. Okay, it is a void method. Just we are setting this particular value. Nothing we are doing. We are not doing anything here. Okay, now you can see it is a bracket is open. We don't have any code inside this particular method. Okay, so back to here. This is we are trying to return null, and what we can understand here, whatever this particular put method we are having, if it is equals to null, this add method will return true. Okay, where we define this particular add method? In the collection. Okay, in the collection we define this particular add method. So same, the add method is implemented inside this particular hash set, and internally we are calling map.put method. Okay, this is the way of calling the add method, and we'll identify how it is implemented internally. So for example, if I'm going to print this particular HS, so it is a reference variable of this particular hash set. Now you can see what is the value we are getting? 1, 2, 3. Only we are getting the key. Only we are getting this particular key. Now why we are not getting this particular value? So to understand this, first what we need to understand the toString here. This is important here. We need to understand the toString here. So nothing here, we don't have any toString information here. But where we can check here, what is the super class for this particular hash set. Now I will go to abstract set here, and we'll identify whether this particular toString is available. Here also we don't have the particular toString, and we need to understand the abstract collection. So here you can see we are having toString here. Now we need to put a breakpoint here. Now you can debug the code. You will understand how this particular toString is executing internally. Okay, we'll debug this particular section later. But finally, if you observe the linked list, okay, array list, and now we are discussing about the hash set. All the methods are calling abstract collection toString method. Abstract collection toString methods are calling internally. Okay, now if I'm going to modify this, because integer cannot understand the what kind of the hash code we are having. Now I'm trying to modify this, and this particular value I'm trying to inserting as a string value. Now we'll debug the same code to understand this particular hash code, how it is going to generating internally. Now you can see I'm calling the default constructor. Now again I'm calling the add method. Okay, we are calling the put method internally. So here we have a hash. If I'm going to expand this, now you can see this is the hash code of the number what we provided, but the number internally it is going to treat as a string. Getting the pen. So earlier we got the same 1, 2, 3, but right now we are getting the different value 48, 690. And if I'm going to see, this object is going to store in the which index location. Now we'll modify the index location. Earlier we insert into the 11 index location. Now we'll see in the which index location this particular values are going to store. Okay, now I'm moving into the put value method. So I don't want to check this all the codes here. Now you can see new node. And what is the I value? Now you can see I value we are getting 2. Okay, earlier we got as a 11. Now we are getting as a 2. So see carefully, based on the hash code. So this is important here. Based on the hash code, the indexes are going to change. Okay, based on the hash code only, the indexes are going to change here. So now we understand. Earlier it is the 11 index location. Now it is a second index location. So if you see, once I come out of this particular section, here you can see in the tab, so second index location. Okay, in the second index location, the value store. So what is the value it is stored? 1, 2, 3. Whatever the key 1, 2, 3 we given, it is stored here. And earlier in the 11th index location, now you can see 11th is null. 11th is null. Now what you understand here, based on the hash code only, the index is going to modify here. This is very important information we need to understand here. Okay, so this is all about the add method, how it is working inside this particular hash set. So same thing if I'm going to call one more value, hash set dot add. For this, if I'm going to call as a 789, now we'll see how the second record is going to insert here. How this particular second record is going to insert here. Now you can see first I'm not debug the code. For the second one, we'll debug the code. Okay, so we'll call this particular put method, and so we'll see hash code will identify. Later also we can identify this. Now what is the hash code we are getting for this? So 54, something like 648. This is the different one. Okay, earlier we got the something 48. Okay, earlier we got some 48. Now we are getting, now you can see what is the value we are getting for this hash? Something like 54. So now what you understand here, hash code is every time it is modifying here. Okay, every time it is modifying it. Now you can see I'm calling this. Now what is the I value we are getting? 8 here. Getting the pen. So what is I value? 8. And what is the first record is inserted? Second index location. Now whatever this particular key we generated as a 789, this object is going to store in the 8th index location. If I'm going to come back to here, expand this, in the 8th index location, we have one more object. So this is the 789 object here. But how it is identifying it? Based on the hash code. So hash code, it will give you the information, the object, which index location you need to store. Okay, this is the important one more, the add method we call here, and we are trying to inserting the value. Finally, we are returning the true or false here. So these are all the two records we are having, 1, 2, 3, 789. Okay, so if you are trying to inserting multiple objects. So for example, if I'm going to insert this same 1, 1 to 3, I'm trying to insert here. After the second record, I will insert here. What happens here? Whenever I'm trying to inserting third record, okay, this particular code will debug, will try to identify for this particular third record how it is going to insert. So for we identify the two records, which index location the two records are going to store. First one is in the something like what is the first one? I think second index location. Second one is in the 8th index location. So we'll identify this particular third one. It will try to store in the which index location. Okay, now I'm trying to debug this method, and we'll debug the put method, and we'll go for the same hash method, and we'll come out of this particular hash method, and we'll call the put value method. So what is the hash code here? Same thing, 48690. Okay, 48690 we are getting here, and what is the key we are having? 1, 2, 3, and what is the value? Value will be same. Every time this particular value will be same. Okay, anyway, now we need to understand here. What is the I value we are having? So if we observe carefully, this condition is not satisfied. Getting the pen. Earlier, for the two records, this particular section is satisfied. Now, whatever the record we are inserting, the third record, this, whatever I'm highlighting, this is not satisfied. Okay, here we are not getting the null. Here we are getting the null because based on this particular tab, we are getting the record here. Let me try whether it will return nothing. Okay, basically we are doing inside initialization. Because of that, we could not inspect this particular value. Okay, what is the I value we are having? Now you can see 2. Getting the pen. So we are getting 2 here. How we are getting this particular 2? Based on this particular n minus 1. What is the n? Here we are getting the length here. What is the length here? 16. So after doing this particular n minus 1, we are trying to work on this particular hash, and based on this particular code, we are getting as the index location. Because if you see in the tab, already 2 records are inserted. First one is the second index location, and the second one which is available inside the 8th index location. Okay, 2 records are already inserted. We are trying to inserting third record, but whenever I am trying to inserting the third record as a duplicate record, what happening internally? So first identifying the index here. Once this particular index is identified, now the section is moving into the else. So observe carefully, p dot hash. What is the p dot hash we are having? 48,690. And what is the hash code we are having here? Now 48,690. So both the hash codes are matching here. Getting the point? Here both the hash codes are matched here. After matching, here we are using the AND operator. Okay, here we are using the OR operator, and here we are using the AND operator. So this is very important, we need to understand here. After this, we are checking here. So p dot key. What is the p dot key? 1, 2, 3. And the p dot key I'm trying to store into this particular k, and I'm trying to test with this particular key. So this particular key also 1, 2, 3. Now observe carefully. This condition is satisfied, and this particular condition is also satisfied. So when this particular condition is satisfied, it will not check this. Okay, it will not check this. Now what you understand here? So this is very important whenever we are discussing the hash map. Hash map internally, it is going to play the role based on the hash code here. Getting the pen here, inserting also it is identifying the hash code, and for updating or deletion also it will identify this particular hash code. This hash code is matched here, and the same way key also matched. Now what I'm doing is, whatever the p we are having, I'm trying to return into this particular e. Okay, now you can see what is the p right now we are having. Here we load the record. Basically we load this particular record, key value 1, 2, 3 object we are having. Okay, now I'm trying to assigning into this particular e. So whenever we are trying to assigning like this, now you can see we are trying to replacing the value. Okay, only we'll replace the value. Getting the point? We are not going to create the one more record here. This is important here. Okay, just now you can see what is the original value we are having, something like object reference here. So we are trying to replace with this particular old value. So this is only the changes we are going to make whenever we are trying to inserting the duplicate record. This is important here. Inside this particular hash set, we cannot initialize duplicate keys here. Getting the point? This is important. If I'm going to print this, how many records we are getting? Only 2. Why we are getting the 2? Here I'm trying to inserting 3 records, but finally we are getting only 2. Getting the point? This particular third record is not inserted into the hash map here because hash code and key both are same. Whenever the hash code and key and both are same, it will override the value, not the key. Getting the point? It will override only the value. This is very important information we need to understand from this particular hash set here. Okay, so any questions? Anyone having any questions regarding this particular add method?
Sir, I have one question, sir. Since the values are stored, they're not sequentially stored, right? Like it's at index 2 and index 8. You cannot retrieve the value using the index value, right?
Yes.
Like index of 0, it's not
No,
stored
that is
in.
not. See, indexes is only we can work on the array list.
Okay.
In the hash set and hash map, it will work based on the hash code.
Hash code. Okay. And no two different values will have the same hash code, right? Like 1, 2, 3 and 7, 8, 9.
Yeah,
They
definitely
both.
it will different. Both we are having
Okay.
the different values.
Okay. Yeah. Thank you, sir.
Okay. Any other questions? Okay. Same way, now I will comment out this because we identify the add method how it is going to work internally. We'll call the add all method. Getting the point. So here I'm going to pass one more object. So we discuss about the where is the linked list? Let me move on to the linked list example. Okay, so here I'm going to use linked list object here. Okay. Otherwise, we'll move on to this array list only. And here I will create a array list here, and here I'm going to pass AL because it is going to take as a object here. Okay, both we are having string. Array list also we are providing the string, and hash set also we are providing string. Now finally, what we need to understand how this particular add all method is going to work internally. Let me debug this particular add all information. So I'm not going to debug this particular array list related example because we already identified in the previous example. So hash set we are calling, and hash set to add all method we are calling. Now finally, I'm trying to enter into this particular method how it is implemented. Now if you see, now we are inside the which class? Abstract collection. Getting the point. So why we are coming under this particular abstract collection? Because this add all method is not yet implemented under the hash set. Getting the point. This is important. This add all method is implemented under this particular abstract collection. From this particular abstract collection, again we are calling add method. Again we are calling here add method. But what is the differences here? So this is only the difference because we are passing multiple objects internally. So this multiple objects with the help of this particular for each loop, again we are calling one by one. Okay, again we are calling this particular one by one. So same thing it is applicable here. So add method we are calling. Now again I'm trying to move this particular add method internally. It is calling map dot put method. Now you can see again we are inside the hash set. Okay, add all method is implemented in the abstract collection, but add method is implemented inside the hash set. Getting the point? This is important. So whatever the common method we have, the common method is already implemented. One of the abstract class called abstract collection. Getting the point? So from the abstract collection, again we are calling the specific class called hash set, and internally we are calling the same put method. The hash method will call first, and it will generate the hash code of the key, and again we are calling this particular put value. So now you can see what is the hash code we are having, 1569. Now you can see 1569. This is the hash code of whatever the value, what is the key we are having, 12. Okay, for this particular 12, the hash code is 1569. Now I'm trying to check this. Now what is the I value? First here. What is the I value we are having? First. Whenever the I value we are having first here, the 12 record is going to store in the first index here. So far how many we are having? First and second and eighth record. Only 3 records we are having. But how this particular first record is identified? Based on the hash code. Okay, so this is we identified. So we are calling the after node insertion. We are going back to the same the loop here. Okay, first add method is completed, modified true, and one more add method we are calling because this is the second record. So I'm going back to the same add method. Now you can see what is the E 45 and what is the is it the second record or third record? So it is the second record. First we call this particular 12. Now we are calling this particular 45. So same method I'm calling, and put method, hash method, and something like okay, we'll come back to this. No need to check this. And put value method. Now you can see hash code. So something like 1665. For this particular 45 key, we are having 1665 as a hash code. Okay. So we'll see what is the What is this particular I value? 1. So this is important. Getting the point. So 12 is different. Okay, 45 is different. Both keys are not same. But now if you see, what is the P we are having? Here we are trying to load this particular object, 12. Getting the point. So how we are loading? Because of this particular index location, we are loading an object from this particular tab. Because based on this particular hash code, we are returning the index as a 1. Because inside this particular index, we have one record. Because of this particular condition is not satisfied, and it is not created the new node. Because now you can see key already having the one record. But key, what we are having? 12. And what is the current key we are passing? Something like 45. Both keys are different. Getting the point? Both keys are different. So now what we are doing here? So first we'll check the hash code. So p dot hash 1569, and current hash is something like 1665. So both hash are different, and the key is also different. And it will try to look up this key not equals to null and key equals to k. So in this case also, totally this expression will fail. Okay, now you can see, else if we are checking, so P it is not a tree node. Now we are moving into the else section. So this is important. Okay, this is important here. So this is whatever I'm highlighting. This is for the initialization, and there is no condition. Getting the point. So I'm trying to providing multiple for loops here based on our requirement. We are defining the different blocks here. Okay. So like in the two string, we don't have a initialization, condition, and iteration. Like it's like an infinity loop we define. But here we are trying to, without the conditional block, we are defining the one for loop here. So only initialization we are having, and only incrementation, something like a iteration. But there is no conditional. Now you can see what is the bin count initially 0. Okay, and here now what I'm doing here. So e value I'm trying to set based on this particular p dot next. So what is the p dot next? Null. P dot next is null. So if you see, whenever we are getting this particular p dot next is null, we are trying to create a new node. This particular node we are going to set into the p dot next. What is the p? 12. Getting the point? This is very important here. So I will give you the diagram first, you will understand. First, what is the value we initialize here? Okay, this much is very important. Otherwise, let me diagram little bit small. Okay, hash code, key, and next here. So how many records we are having right now? So right now we are having something like around 4 records. So I'm trying to creating 4 records here. So we'll identify how this particular values we are having. So I will try to provide only key. First one, what is the key we provided here? Let me see inside this particular tab. First record is a 12. Okay, here I'm going to provide 12. So next, as of now, null. Okay, all the records whatever we created, next records are null. And okay, and what is the second record? In the second index location, 1, 2, 3. Okay, in the second index location, we provided 1, 2, 3. This is first, and this is second, and so I think this is the 8th one. We'll see what we are having inside the 8th year. Something like 7, 8, 9. So this one we are having 7, 8, 9. And so we are trying to inserting one more. So right now, only 3 records we are having. So with the help of this section, with the help of this particular line number 637. Okay, with the help of this particular 637. Okay, now observe carefully what I am doing here. I am trying to create a new node here. This is very important information we need to understand. So when indexes based on the hash code, if the indexes is same, how we are inserting here? So we are not inserting with a new record. We are trying to make as a p dot next. What is the p right now? What is the p right now? This is the p. Okay, the 12 record, whatever the 12 record we are having, this is the P. Now if you see this null, it is going to connected with this particular object. Getting the point? Whatever the null we are having, this particular null is replaced with this object here. So this is the 45 value we are providing. Okay, this is the 45 value. So see the communication how it is happening internally with help of this particular node concept here. So because of that only the last value we are providing next references. It's like a next node references we are providing. Okay, so this is important, we need to understand. Now you can see P dot next we are having. Now remaining conditions will not satisfy, we come out here. So we'll see where is the P. I will try to expand this particular P. I will show you how this diagram is working internally. Okay, so key and value. Key and value. Right now, we don't have the particular next information. So how we identified in the linked list, the same way we cannot identify this. Why we cannot identify? Because what is okay, so you can see there is no the public information. This variable we cannot access outside of this. Because of that, we could not understand this. Okay, so now what you need to understand here, only what is the information we are getting here? Key and value. Key and value we are having. But internally, what we can understand here, this particular P record. This particular P record now it is having the next references to this particular 45. Okay, this is important. But so far, this particular two records we don't have. Still, they are making null here. These are all the independent record. But this record is now it is dependent with this particular 45. Okay, one more I value if I'm going to get 1. Getting the point. This is important. If I'm going to get one more I value as a 1, what happens internally? So first we load this and we are going to check if this record having any next record, and we load this. Finally, the one more record, whatever we are going to insert, this node is going to communicate it with like this. So this is the chain process we are going to have internally. But everything internally it is going to depends on the key as well as hash code. Okay, so any questions on this particular diagram? This is very important diagram we are discussing. Anyone having any questions? Okay, so if you don't have anything, now I'm going to clear this diagram. Now we'll back to here. So E, what is the E value right now we are having? Let me inspect this. So it is a null. So if it is a null, this if condition is not going to satisfy, again we are coming back to the normal code what we identified. Okay, so again we'll see after calling this, we'll go back to the put method, and add method we are calling, and we are trying to repeat the loop one more time. So right now, third record we are inserting something like a 78. We'll debug the put method, value method, hash code method, and the put value method. So we'll see. So again, what is the I? I value 1. If you see, hash code is 1761. Getting the point? Hash code is 1761. Hash code is different, key also different, but only index is same. Only index is same. So in the same index, as of now, how many records we are stored? 2 records. Okay, 12 record we stored in the same index, and 45 also we stored in the same index here. So these two under the first index location. But right now, one more record also we are going to insert here. So now you can see this condition is not satisfied. We are checking with the else condition. So this entire condition will fail here because hash code and key not satisfied. So again we are coming back to the if the else section. Again we are trying to discuss about this particular loop here. So now you can see next is null. No, the whatever the next we are having, this particular next is not null. Now I'm trying to load this. Okay, this particular P is having one next record. If I'm going to expand this, we'll get the 45 information. Getting the point? Here we are having 45 information. So this condition will not satisfy. we'll come back to this particular else section. We'll see how this particular else section is implementing. Okay, e dot hash here. What is this particular next? So basically this e contain the 45 information. This e contain the 45 information. So where we are loading this? Here we are loading. So this particular highlighting, whatever I'm trying to highlight here, this highlighting part we are trying to load, and the next record I'm setting into the e variable. Okay, and what is the e dot hash? What is the value we are having? 1665. But right now 1765 something. Yeah, 1761. Hash code is different. Okay, key will be different, and this condition will not satisfy. Whenever it is not satisfying this, whenever it is not satisfying this, now what I'm doing is I'm trying to make whatever the next record we are having, I'm trying to set into this particular p. Okay, now p is replaced with e. So what you need to understand, basically p right now we are having 12, and e right now we are having 45. Okay, now what happens internally? So this particular p, now it is going to replace with the 45, and 45 cannot have a next year. So see carefully the hierarchy right now. So this is the hierarchy we are having. Okay, this is the hierarchy as of now we are having. This is the 12 one, and this is the 45. So this node is connected to this particular 45. This, it is not connected to anyone. It is null. Okay, it is null. Getting the point? This is important. So if you observe, this condition will not satisfy. So we'll come back to the line number 645. Now you can see we are inside the 645. So second iteration is repeating. Now p dot next. What is the p basically? If I'm going to expand this particular p, it will return as a 45 record. Now you can see 45. How we are getting the 45? This line. The line number 645 we are replacing here. Okay, so this is important. Now the next we don't have, this condition will satisfy. Okay, this condition will satisfy. So we are creating the new node, and this new node is going to set to the this object here. Okay, if I'm going to create here, it will create like this. So this node, now it is pointing to this, and the 78 we are providing. Now see the hierarchy. 12 is depending on 45, 45 internet depending on the 78. But these three objects, okay, these three objects are storing in the which index location? 1. So this is very important here. In the first index location, right now we inserted 3 nodes. But if you open this, we'll get only 1. If we expand another node, you are going to see the hierarchy, how it is implementing. So now you can see, we discussed this particular line. It is trying to create a next node, and it will try to set as a p dot next here. Okay, p dot next. And finally, we'll come out of this particular put value method. Okay, so we are checking this. Now this is the last iteration we are calling. So last iteration we call here. Finally we set the values. Okay, this is all about the add all method, how it is implementing internally. Anyone having any questions regarding this add all method or any add method? Okay, if you don't have anything, so I want to show you some code here, like what I implemented. Now you can see this is the some of the real-time applications we are going to look like here. This is the one of the Spring Boot application I implemented. Okay, so this is our main application is going to run. Oh my God, it's little bit slow. Okay, so here only I implemented. Now you can see these are all the controllers. So only one controller I'm having, and I come up with a different endpoints here. So this is for the save user, and this is for the home page purpose I implemented, and this is for the login, and this is purpose for the registration, and so something like a save login related another endpoint I implemented. Okay, here I'm checking some condition. Based on the condition, it will redirect here. Okay, these are all the one class I created, and internally these are all the methods we provided. So these are all the different endpoints. Now we'll go back to the database and model classes and services. Now if you see, this is the service we internally we created. Save user. Okay, something like find login. Getting the point. And you can see the model classes. Address class I created, contact I created, login I created, and person I created. Getting the point. These are all the some different classes we created here. Now what you understand here, same way, this person we are going to use inside the list. If I'm trying to insert a list of persons, we'll try to create like this. Okay, we'll try to create like this and we'll use in the real-time application. It's like a sample application I created. Let me see if I'm going to provide. I think in the personal life, I may have some additional information. So this is taking some time to load. We'll wait. Okay, this is for. Okay, so we'll identify the internet banking here. This internet banking will contain lot of classes. Now you can see here I'm having different packages here. First one is the internet banking. I created one bean, config, DOO, exceptions, model, repository, resource, service, token, util. We have a different packages I created. So same structure we are going to use in the real time also. So same structure. This structure is not going to modify. The naming convention will be different, but this is the only the way of creating the different packages here. Okay, inside this particular package, if I'm going to expand here, we have a multiple classes here. Okay, for the simple purpose, now you can see how many the model classes I created. This is also one of the bank application I created, account I created. Okay, account to transaction I created, account to type I created. Getting the point. So it is the enum. So now you can see here we are using the enum. So we discuss about this particular enum also. Current account and saving account. Okay, address I'm creating. So inside the address, now you can see how many fields we are having. These are all the different fields. So address ID, address 1, address 2, address 3, city, state, and zip code. Okay, this is an address. And we have a something like a administrator class. So I did some code I commented here. Now you can see ATM. These are all the different properties we are having. ATM ID, ATM number, customer, and CVV, issue date, getting the pin, start date and expire date, ATM pin, and when we change the pin, and so cancel ATM. Getting the pin. These are all the different fields we are having inside this particular ATM. So ATM card tracking, ATM card tracking information, track ID, pin change date, so cancel the ATM card, getting the pin, how many days the pin we can change, and so if I want to apply the new card, so these are all the some boolean, and it is depending on internally ATM. Okay, so ATM locations, so wherever we are having some locations, these are all the different properties for the ATM location. So now you can see I created multiple classes here, so you can check this. So this is the bill status, so draft, processing, and completed, something related to bills. So this is a check service. Okay, check status. Okay, this is the bill status and check status, little bit same here. Okay, and fund transfer. These are all the fund related transfers here, and in between contact here. Now you can see contact ID, mobile number, email, is primary phone or not, something we are having, and it is mapped with the person. Okay, and so something like monthly average balance, what we need to maintain here. These are all the monthly related. So user roles here, and user object. So user object will contain user ID, username, and password. So we are having something different to joins I made here, but these are all the different classes I created. So same way Based on our applications, we are going to create the model classes like this, and repository. These are all the repository classes I created. Now you can see, so account repository, address, contact, person, role. We have some different. So token related, because we'll try to implement the like a string security, because the token is very important concept we need to understand. These are all the some resource classes. Okay, this is the way we'll create the all the classes in the real-time scenarios here. Okay, this is the hierarchy we need to follow, how we are going to, how I created as of now here. Okay, we'll discuss these particular sections whenever we are completing, after completion of this particular spring here. We'll try to cover up the one by one example, how it is going to work internally. So far, just understand here, like whatever we are discussing the collection framework, just for understanding, I'm providing this information, how we are going to create the real-time applications here. Okay, it is one of the real-time applications here. So any questions here? Okay, so if we don't have anything, so we'll continue the same, whatever we are trying to discuss this particular asset. We have a different methods inside this particular asset. We'll continue this particular continuation tomorrow morning. Okay, so if we don't have anything, we'll continue tomorrow.
Thank you, sir.